This device is called a Coulomb apparatus. It measures static electric forces. The two spheres are charged electrically. And they will repel each other. The forces between these two balls causes the wire to twist. The water here in this container dampens out the oscillations. The stronger the force, the more the rope twists. There. A laser reflects on this tiny mirror and measures the twist. The laser's reflected light lands on this chart. The chart measures how much twisting is going on. Twice the force, twice the twist, twice the distance. All right, let's get started. The balls are initially uncharged, and so the chart over here is reading about 0. Initially, the balls are 10 centimeters away. Both of them get charged, and the rope begins to twist. Now, to what distance should I move the balls apart in order to measure half the original force? You see, the force is proportional to the square of the distance. This means that the original force was proportional to 1 over 10 squared, or 1/100th. The second force is proportional to 1 over radical 2 times 10 squared, which is 14 squared. That means 1 over 200, half as much. The correct distance is 14, because 14 is radical 2 times 10. At about 14 centimeters away, you get half of the force. This is because 14 is radical 2 times 10, and Coulomb's law, forces, decreases the square of the distance. All right, whole new experiment. The balls are all charged up, and so over here we're getting a reading of about 14. Now I have this device which will take half of the charge off this ball. Now what will the reading be? Over here on the chart, we see the reading settling. This may take some time. At about 7, half as much. From this experiment, we discovered that the force is proportionate to the quantity of charge. Now there's 2 charges, so we say it's proportional to the product of those 2 quantities. We also discovered earlier that it was inversely proportional to the square of the distance, and that's Coulomb's law.